In this video, I'm going to talk about limits. In particular, I'm going to give an example of how to find limits for a function at a specific point. So my function is y is equal to f of x is equal to 1 over x minus 1. So before I do that, what I'm going to do, I'm going to draw the number line. So let's say this is my 0. Let's put the 0 here. And of course, it extends to the left and extends to the right. And let's say this is my 1. I kind of want to find out what happens to this function as x approaches 1. Okay, as x goes towards 1, what approaches to the value of this function, 1 over x minus 1. So let's start off with the value of the function from the right. So let's say I'm going to create a table x f of x. If x is let's say 1.5, f of x is going to be 1 divided by 1.5 minus 1, which is going to be 1 over half or 0.5, right? That's going to be just 2. 1 divided 0.5 is 1 over 2. That's going to be just 2. Now, what if I go to 1.4? Again, it's going to be 1 divided by 1.4 minus 1, that is 1 over 0.4. 0.4 is, by the way, 4 over 10, right? So 1 divided by 4 over 10, if you simplify it, it's going to be 10 over 4. That is going to be 5 over 2, that is 2.5. So 2.5. Similarly, I could keep going down. 1.3, 1.2, 1.1, 1.01, 1.02, and so on. If I plug in these values, this is what I get. For 1.2, it's going to be 5. For for 1.3 is going to be 3.33. For 1.1 is going to be 10. For 1.01 is going to be 100. Actually, I meant to say 1.001. It's approaching 1. So that's going to be 1,000. And next, I could have 1.0001. That's going to be 10,000. And as you can see, as you approach the point 1 from the right-hand side, how does f of x behave, or how does y behave? Y is equal to f of x, which is 1 over 1 minus x minus 1. It is getting bigger and bigger and bigger. That means it's going towards positive infinity. So limit x approaches 1 from the positive side. Okay, that means x is going towards 1 by taking little steps. Okay, by taking little steps from the right hand side, going towards 1, and the function f of x approaches positive infinity. Similarly, you can create a graph like this. You'll see that it goes towards negative infinity if you approach 1, or if x approaches 1 from the negative side. Let me go ahead and create a small table. As you can see in this table, x is approaching the number 1, but this time from the left-hand side, okay? Anything to the left of 1 is going to be less than 1, right? So I started off with 0.9, then I'm getting closer, 0.99, I'm getting even closer, 0.999, and even closer, 0.9999. As you can see, for 0.9, the value of the function 1 over x minus 1 is going to be negative 10, negative 100 for 0.99, for 0.999 is negative 1,000, for 0.9999 is negative 10,000, and it's getting smaller and smaller. So what happens if you approach the point 1 from the left hand side, the function limit x approaches 1 from the negative side. I put a negative on top of 1. F of x is actually going towards negative infinity. So as you can see, if you approach from the right side, the function approaches positive infinity. If you approach from the left-hand side, the function approaches negative infinity. So for approaching the point 1, either from the right or from the left, do not give you the same answer. If you approach from the right, you get positive infinity. If you approach from the left, you get negative infinity. So this function does not have limit. Does not have limit at which point x is equal to 1. If for a function the limit exists, it must be the case regardless of how you approach, whether you approach from the right or approach from the left, it should always give you the same value. All right. So this is how we write left limit. This is how we write right limit, and this is how we write left limit. So for a function, if limit exists, it must be the case limit x approaches from the positive side some point a, okay? Some point a, f of x must be equal to limit x approaches the point a from the negative side, f of x, and that is what we call the actual limit x approaches a, f of x. So please do remember, doesn't matter which side you approach the point of interest, regardless of the direction in which you approach the point, the limiting values should be the exact same values. And that's when we say that a function has limit. Otherwise, we say the function does not have limit. In this case, I gave you an example where the function does not have limit. I hope that this discussion was helpful. Thank you very much.